Session 8.1 Basics of Hypothesis Testing. Example of the null hypothesis and the alternate hypothesis. Look at this example. Air pollution has become a serious health problem in many cities. One of the forms of air pollution that health officials are most concerned about is particulate matter, the PM. Okay, PM is one form of the pollutants, which refers to fine particles that can be trapped in the lungs, increasing the risk of respiratory disease. Some of the PM in the atmosphere comes from the car exhaust. So one important way to reduce the PM pollution is to design automobile engines that produce less PM. And for an example, we'll show how hypothesis testing can pay in this effort. We find one form of the pollutants that is exhaust from the cars. Okay, so this is gonna be my old cars, and they produce a lot of the PM. Okay, the PM is one form of the pollutants. So now we want to protect our earth. So what we're gonna do? We're gonna redesign the new car. Okay, this is my new car with the new automobile engines, and hopefully these cars will produce less PM compared with the old one. So this is gonna be my example. So how can we prove it if my new engines is gonna be produce less PM compared with the old one? We're gonna set up the hypothesis testing. A study says that the mean amount of the PM produced by the cars is greater than or equal to 35 milligrams of the PM. So we find that the old car here, they will produce the mean amount of the PM is going to be greater than or equal to 35 milligrams. Okay, this is my mean amount of the PM. If we design the new engines, and hopefully this is going to be produce less PM. So we are looking for the mean amount of the PM will produce strictly less than 35 milligrams. Does that make sense to you guys? The old car, they produce the mean amount of the PM will be greater than or equal to 35 milligrams. If the new design of the car could reduce the PM amount, so the mean amount of the PM should be strictly less than on this number. Okay, so this is how we set up our hypothesis testing. And for the first one here, this guy, we will call, this is going to be the null hypothesis. Okay, H0, null hypothesis. And this one, we call, this is going to be H1, the alternate hypothesis. Okay, alternate hypothesis. A hypothesis is a claim or statement about a property of a population. So let's look at our examples here. We are working on the hypothesis testing, and this procedure is going to be testing a claim about the property of the population. So right now, we want to test it if the mean amount of the PM should be reduced. And we have the null hypothesis, the H0 here. The H0 represents the null hypothesis. And the null hypothesis is always contains the equality, either using the equal to, or less than or equal to, or greater than or equal to. Okay, null hypothesis is always have this free choice. From our example, our null hypothesis should be greater than or equal to, right? Because we test out the mean amount of the PM is greater than or equal to 35 milligrams. And for the alternate hypothesis, we use the H1 in this book. If you guys reading other statistic book, they may have the HA in here. All of them are represent the alternate hypothesis. And for the alternate hypothesis, we always use the not equal to, strictly greater than, or strictly less than. And the null and alternate hypothesis, the null and alternate hypothesis are complementary. Complementary means they're gonna take out everything. Okay, let me talk about the alternate hypothesis first. We do have three types of alternate hypothesis. The first one, if we are working on the mean strictly less than 35, means like we are working on the left tail test. Okay, we assume this is a normal distribution. If you look at your alternate hypothesis, this is a strictly less than, that means we are working on the left tail. If your alternate hypothesis is strictly greater than, okay, strictly greater than, that means we are working on the right tail test. Last one, a two-tail. If your alternate hypothesis is working on not equal to, okay, not equal to 35 milligrams. So this means we are working on the two-tail test. Okay, you have to know which tail test you're working on it. It all depends on your alternate hypothesis. Alternate hypothesis strictly less than, that'll be left tail. Greater than, that'll be the right tail. If that's a not equal to, means that'll be the two tails. Okay, so from our example, our null hypothesis is greater than or equal to. And then alternate hypothesis is strictly less than. Okay, so this one, when we have a strictly less than, you know that we are working on the left tail test, left tail test. And remember I say the null hypothesis and alternate hypothesis is a complementary. Okay, means they're gonna take out everything. If this is a greater than or equal to, this guy has to be strictly less than. So first step, you guys need to know how to write down your null and alternate hypothesis. First, null hypothesis. We are working on these four population parameters. Okay, for the session 8.2, we are working on the population proportion. We will be using the P. 8.3, we'll be working on the population mean. 8.4, we are working on the population standard deviation or population variance. You guys need to remember all those notation, okay? When you guys working on the null hypothesis, first, decide which population parameter you are working on it. Are you working on the proportion or mean or standard deviation or variance? And then they will give you the number. This is the number that you want to test for it. Just like our example, our mean amount of the PM will be 35. So I do have a 35 in here. So this is your null hypothesis. And the null hypothesis, you also have these two choices. Equal to, less than or equal to, or greater than or equal to. Okay, second, you need to pick one of them. Depends on your claim statement. Okay, with the claim statement, decide are they using equal, less than or equal to, or greater than or equal to. Now we're gonna work on the alternate hypothesis. Alternate hypothesis, again, you need to decide which population parameter we are working on it. And you do have a free choice for the alternate hypothesis, either not equal to, strictly greater than, or strictly less than. And again, each not and the alternate hypothesis is always a complementary. If this is a equal, this is gonna be not equal to. If this is a less than or equal to, this guy has to be greater than. And if this is a greater than or equal to, this guy has to be strictly less than. So this is the first step to decide the null and alternate hypothesis. And then you need to know which tail test you're working on it. So look at the alternate hypothesis. If you have the not equal to, you are working on the two tail. If you are working on strictly greater than, that will be right tail. If you're working on strictly less than, that will be the left tail. Okay, so these two parts are gonna come back after we have the first three example. Number one, claim high school teachers have incomes with a standard deviation that's less than 23,000. A recent study of 145 high school teachers' income saw a standard deviation of 19,000. Okay, so I have the claim statement here. When you guys working on the original claim, the null and the alternate hypothesis, you only need to pay attention of your claim statement. Okay, only work on your claim statement. So here, the claim statement is going to be your first sentence. Express the original claim. So means I want you guys translate it from the English to the mathematical equation here. First, decide which population parameter they are working on it. Are they working on the mean? Are they working on the proportion, standard deviation, or variance? They are working on the standard deviation, right? The standard deviation. And standard deviation, that is less than 23,000. Okay, so translate it from English to mathematical equation here. So we have standard deviation strictly less than 23,000. Okay, now state the null and alternate hypothesis. Okay, now let's look at the original claim here. We have a standard deviation strictly less than 23,000. Remember, strictly less than, it happens on the null hypothesis or alternate hypothesis. Go back to look at here. Okay, strictly less than. So strictly less than, that will belong to the alternate hypothesis. So we're gonna write it down for your alternate hypothesis. Standard deviation strictly less than 23,000. Now you're gonna decide what you're gonna put for your null hypothesis. Remember, these two guys is always like a pair. So if you choose the strictly less than here, your null hypothesis is going to be greater than or equal to. Okay, these two has to be complementary. So my null hypothesis is going to be the standard deviation greater than or equal to 23,000. Okay, which tail test we are working on it? Left tail, right tail, or two tail? That'll be left tail test. Okay, because this is going to be strictly less than, so we are working on the left tail test. Number 2, the claim statement. The mean weight of beauty pageant winners is 116 pounds. Again, when we're working on the null and alternate hypothesis, we only need to pay attention for your claim statement. Other than that, you could just ignore it. So first, write down your original claim. Translate it from English to mathematical equation. Which population parameter you are working on it? Proportion, mean, standard deviation, or variance? That would be the mean, right? That would be the mean. So mean is 116 pounds. Right? Mean is 116 pounds. Okay, the null and alternate hypothesis. For your original claim, you have the equal. Remember, equal, it should be go to the null hypothesis or alternate hypothesis. Equal should be the null hypothesis, right? And if you have a equal for your null hypothesis, alternate hypothesis will be not equal to. Okay, equal should go to your null hypothesis. And for the complementary, that will be not equal to. Okay, left tail, right tail, or two tail? Two tail, right? Okay, number 3, claim statement. At least 45% of the internet users pay bills online. So only look at the claim statement. First, think about it. What is your population parameter? Proportion, mean, standard deviation, or variance? They never mention about the mean or standard deviation, right? So that should be like the proportion. Proportion. So what is the inequality of at least 45%? That would be P greater than or equal to, right? P greater than or equal to. That would be our original claim. So now think about it. Greater than or equal to should be your null hypothesis or your alternate hypothesis. That would be your null hypothesis, right? Greater than or equal to. Okay, the null hypothesis is always contained with the equal. Greater than or equal to, less than or equal to, or equal. So think about it. What is your alternate hypothesis? Alternate hypothesis should be opposite with this guy. So that will be less than, strictly less than. Opposite, your alternate hypothesis should be opposite with this guy. So it should be strictly less than. And then think about it, left tail, right tail, or two tail. Strictly less than, right? So it should be left tail. Okay, so this is gonna be the first two steps. Write down the original claim, write down the null and alternate hypothesis. Okay, now you guys know how to write down the null and alternate hypothesis, and let's go back. Look at this slide. I just teach you guys what are the null and alternate hypothesis, and I say the null hypothesis with this features, alternate hypothesis with this features. Okay, right? And we finish the example 1, 2, 3 here. Okay, now I want you guys highlight this plugin here. These books, almost all other books and almost all professional journals express the null hypothesis using only equality. Means like if you guys reading other statistic book or the professional journals, if you see they working on the hypothesis testing, you only see that the null hypothesis is always equal. They don't have a less than or equal to or greater than or equal to. But for the alternate hypothesis, it's going to be looks like exactly same as ours, not equal to, greater than, or strictly less than. I want you guys keep in mind that I'm right, and other statistic book or your other professor, they teach you guys like this way is also right. But why we have like two different answers from here? This is related to the history of the statistic. Long times ago, not all the people have the computer, and the computer design is only just like our keyboard right now. On your keyboard here, we only have a strictly less than or strictly greater than. We don't have the less than or equal to or greater than or equal to. And the original idea for the statistic, when we write down the null and alternate hypothesis, they decide write it like this way. However, when they type it in using the computer, they find it out they have a hard time to find out these two keys. So they just want to make it easier. They take out like these two parts. They would just consider null hypothesis is always equal. And we still keep the alternate hypothesis like this. So nowadays, like people just accept it. We could write the null hypothesis with the equal sign, alternate hypothesis with these three guys in here. If you're working on my homework or exam, if you want to write down the null hypothesis only equal sign, that's okay, that's fine. I don't take out you any credits, okay? But I would say that If you guys understand how to plug in like this part here, it will be easier for you guys to determine the alternate hypothesis. And also, like everything is gonna be make more sense because this is a complementary. So again, if you guys go to take the statistic class for the upper division and your professor teach you guys only put the equal sign, this is okay, this is white, and I'm also white in here. But for my class, I will just click like this one. Okay, the original idea for the statistic on the hypothesis testing. Okay, next step, we're gonna talk about select the significance level alpha. The probability that we use to determine whether an event is unusual is called the significance level of the test and is denoted alpha. This is the same alpha introduced in chapter 7, where we define the confidence interval to the probability 1 minus alpha. Common choice for alpha are 0.05, 0.01, and 0.10. Remember we talked about the alpha from the chapter 7. On the chapter 7, if we want to find the critical value, the critical value is always on your y-tail. That will be the z-score on your y-tail here. And the alpha will represent the area of the left tail plus the area of the y-tail. If we want to find it out, we could do 1 minus the confidence interval in the middle here. Right? This is from the chapter 7. And the same alpha we're working on it, we're gonna apply it for the hypothesis testing. The difference is chapter 7, we always working on two-tail for the confidence interval. But for the chapter 8, it depends on your alternate hypothesis. We can have a left tail, right tail, or two-tail. So if we are working on the left tail here, we call the area of the left tail, this part will be equal to your alpha. Okay, and the alpha, this is represent like the probability that the event is unusual. It means like this is the probability that the event it won't be happen. And for the majority part here, this is talking about the probability will be usual. Okay, and if you're working on the white tail, the area of the white tail will be equal to the alpha. So the event if lying on this part, that will be the unusual event. And if you're working on the two-tail test, your alpha will be the sum of the area of the left tail and the right tail will be equal to the alpha. So for example, if my alpha equal to 0.05, so you know the area of the left tail here, that will be equal to 0.05. If you're working on the right tail, alpha will be equal to 0.05, talking about the area of the right tail here. But if you're using the 0.05 for the two tails, make sure you're going to divide it by 2. Means like for each of the area here, that will be 0.025, 0.025. So this is going to be the alpha. Test statistic. Test statistic is a value used in making a decision about the null hypothesis and is found by converting the sample statistic to a score with the assumption that the null hypothesis is true. So this is one of the formula for the test statistic. And remember, we are working on 4 population parameters. We are working on the population proportion, population mean, population standard deviation, and population variance. And each population parameter will have their own test statistic formula. And I just use this example, this formula, that is for the population mean, okay? So let me use the previous example to explain the idea for the test statistic. Okay, remember the first example we talked about it? We perform the hypothesis testing to reduce the mean amount of the PM produced by the car. At that time, we know our null hypothesis, the mean amount of the PM greater than or equal to 35 milligram. An alternate hypothesis, the mean amount of the PM has to be strictly less than 35 milligrams. So either one of them should be true. All right, we're working on the hypothesis testing. Either we could prove this is true. If this is true, means our new design engine failed. We can't reduce the mean amount of the PM. We still have get a lot of the pollutants produced by the car. But if we could prove that this is wrong, means alternate hypothesis is gonna be true. That means our new design engine, it works really well. We reduce the mean amount of the PM strictly less than 35 milligrams. But how do we know we're gonna be reject or fail to reject? So let's look at the pictures here. We are working on the normal distribution, and we say that we are working on the left-tail test because our alternate hypothesis is strictly less than, so we know this is the left-tail test. And then we know that the area of the left tail here, this is your level of significance. Level of the significance is always given, either 0.05, 0.01, or 0.10. And look at the definition for the test statistic. We assume the null hypothesis is true. Okay, the null hypothesis is true. Means we believe that this guy is true. So we're gonna say we assume the H0 is true. It's gonna be on this big part of the area. And for your alternate hypothesis, it's gonna be somewhere of the left tail here. So now when we do the sampling and we get all the values from the data, we could calculate the test statistics. So when we're doing the sampling, let's say we do have a 40 cars and these 40 cars are new design. So we try to measure the amount of the PM produced by these 40 cars. So I have the N equal to 40 because I have a sample size 40, and then I get a set of the data. I will use this set of the data to calculate the sample mean here. So I have the sample mean, I have the N equal to 40, and then the population mean will be equal to this guy, the 35 milligram. And they're supposed to give me the population standard deviation. So we get all the values from the data, and then we could put it into the formula to find out the z-score. Okay, this is called the test statistic. Now we're gonna look at the test statistic. If your test statistic is located somewhere like here, that means we're gonna reject the null hypothesis because my test statistic, this is represent all my sample data, and this is lying on the alternate hypothesis. So that means we're gonna reject the null hypothesis, and we believe alternate hypothesis is gonna be true. So that means the new design of the engine, they reduce the amount of the PM. But if your test statistic located somewhere like here, okay, the test statistic located in this part, so that means we will say fail to reject, okay, fail to reject. We believe the null hypothesis is gonna be true. That means our new design engine is failed. They can't reduce the mean amount of the PM less than 35 milligrams. So this is the idea for the hypothesis testing. How could we collect the values from the data and plug into the formula to get the test statistics C here? And then we're going to look at the C where it's going to be located to see we're going to reject or fail to reject. So this is the idea for the hypothesis testing. We do the sampling, we collect all the values from the data and plug into the formula, find out the test statistic. And then we're gonna look at the test statistic, where it's gonna be located. If this is located in the alternate hypothesis, we're gonna say reject, okay? We believe alternate hypothesis is true. But if the test statistic located in here, means fail to reject. We don't have a sufficient evidence to say this is wrong. So we believe that this is gonna be true. But think about it. I have the alpha and I have the z-score here. how can we compare these two values? Remember, the z-score is the value from here, and your alpha is talking about the area. So this is two different things we can't really compare for. So now we're gonna introduce two methods. The first one, that will be the p-value method. Okay, p-value, the definition: probability of getting a sample more extreme than the ones observed in your data, assuming h0 is true. So you know that the p-value will be the probability. Probability means like the area. The p-value is talking about the area getting the sample more extreme than the one observed in your data. So let's look at the left-hand example here. Right now, forget about the level of significance, reject or fail to reject. Let me focus on the p-value. What is the p-value? We talk about the test statistic, right? We have the test statistics z here, and it represents your sample data. So when we say the p-value is a probability of obtaining a sample more extreme than the ones observed in your data, what I'm basically saying that this value of z comes from my sample data, so all this value here is going to be to the left and more extreme than this one. And the reason I'm counting to the left is being more extremist, because this is the left tail test. So you could think about it, all the data like to the left here, this part will be more extreme values. And the p-value is the area talking about on your left tail here. Okay, this is gonna be your p-value. Okay, so what we're gonna do, we're gonna use the test statistic. Okay, we have the z-score here. We use the z-score here to find the p-value, means use the z-score, find the area from the left. And then we use the p-value to compare with your significance level. For example, this is gonna be my significance level. Okay, the area of the left tail, this is gonna be my level of significance. And I find it out my test statistic is gonna be located in here. And we use the test statistic to find the area, to find the p-value. So means like I'm gonna highlight this part. And this is gonna be the area for your p-value. If we're using the p-value method, right now we could compare the p-value with the significance level, because both of them is talking about the area. Which one is going to be smaller? Is the p-value smaller or the significance level smaller? Obviously, p-value is going to be less than or equal to the significance level. If p-value less than or equal to the alpha, we're going to reject it. Okay, if you remember the previous slide, the picture here, this part should be the alternate hypothesis. So we already know that if the test statistic is located in here, we're going to reject the null hypothesis because the alternate hypothesis is true. Okay, or if this is going to be your significance level and your test statistic is located somewhere like here. So we draw the line. So where's your p-value? This part will be equal to your p-value. Right? The green part here will be equal to your p-value. And now we're gonna compare forward. Which one is gonna be the larger value? Is the p-value is larger or the significance level is larger? Obviously, p-value will be greater than the alpha. So if it happens p-value greater than the alpha, we're gonna fail to reject the null hypothesis. Again, think about it, the previous slide, this part, the big part area, we assume the null hypothesis true. If your test statistic is located here, means the null hypothesis is gonna be true. So we're gonna say fail to reject. Fail to reject means we don't have a sufficient evidence to say the null hypothesis is wrong. So we believe that the null hypothesis is true. So this is the idea of the p-value. I want you guys highlight this part. Highlight this one. You guys need to remember how to draw the conclusion for your p-value method. One more time, you need to use the test statistic to find the p-value. Okay, given c-score to find the area from the left. And use the p-value, compare with your significance level to see reject or fail to reject. Okay, highlight this part here. And we only talk about the left tail example. So one more time, if you are working on the left tail, the p-value will be equal to the area of the left tail. If you're working on the right tail, so the area will be equal to the p-value will be on your right tail here. If you're working on two tail, so two tails, talking about the area equal to your p-value, talking about the both tails, okay? So if you find the p-value, you need to do area to the left times 2 or area to the right times 2 here. Now let's try the example. Assume that the significance level is 0.05. Use the given information to find the p-value. State the conclusion about the null hypothesis. The test statistic of z-score equal to 1.45 is obtained when testing the claim that p strictly greater than 0.4. Okay, so we want to first find out the p-value, and then I want you guys to draw the conclusion about the null hypothesis. This is talking about you want to reject or fail to reject. The test statistic is given in here. When they're testing the claim, the P stands for population proportion. We are working on the proportion. P strictly greater than 0.4. Okay, first step, I need you guys write down the null and alternate hypothesis. Just like the example 1, 2, 3. And then tell me it's going to be left tail or right tail or two tail. Okay, so this is going to be your original claim. P strictly greater than 0.4. Remember, strictly greater than should be go to the null hypothesis or go to the alternate hypothesis. It should be the alternate hypothesis, right? Alternate hypothesis, it can be not equal to, strictly less than, or strictly greater than. And figure out what is the null hypothesis. The null hypothesis should be the complementary with the alternate hypothesis. So it's going to be doing opposite with this guy. That will be less than or equal to. Okay, left tail, right tail, or two tail. That will be right tail test. Okay, right tail test. Now, we will have the picture with the right tail test. And then the test statistic is given, z equal to 1.45. So we assume like here is about 1.45 here. And we want to use the test statistic to find the p-value. Remember what is a p-value? P-value will be equal to the area of your right tail. So means like here. Okay, area of your right tail will be equal to p-value. Okay, how can we find the area? Remember the chapter 6? If they given the z-score, how can you find your area? We'll be using either normal CDF or inverse norm. Okay, so we're going to use the normal CDF. Lower value will be 1.45. Upper value will be here, 1E99. Use your calculator. Okay, you should get 0.0735. Okay, so the area of the right tail means the p-value will be equal to 0.0735. And then now we need to draw the conclusion about the null hypothesis. So what we're gonna do, we're gonna compare with your significance level. Compare these two numbers. Should be less than or equal to or greater than. So remember how to compare with the decimal, digit by digit from the left to the right. So I have a 0, 0, 7, and 5. So 7 is greater than 5, right? When the p-value is greater than the significance level, you're gonna reject or fail to reject. Fail to reject, right? Look at here. Okay, when the p-value greater than the significance level, you're gonna fail to reject. One more time, highlight this part. You guys need to remember this guy. Okay, so what we do, we have the original claim statement. First step, write down the null and alternate hypothesis. Design left tail, right tail, two tail test. Then use the test statistic to find the p-value. The p-value can be the left tail area or right tail area or the two tail area. Depends on your testing here. After that, compare with your significance level. Significance level is always given. And then you're gonna draw the conclusions, reject or fail to reject. Okay, try the next example. Assume that the significance level is 0.05. Use the given statement to find the p-value. State the conclusion about the null hypothesis. And the test statistic is going to be negative 2.13. It's obtained when testing the claim of p equal to 1/4. So first, draw the null and alternate hypothesis. So equal is could be go to the null hypothesis. What is the alternate hypothesis? Opposite of this guy, so that will be not equal to. So left tail, right tail, or two tail? Two tail. So we have the pictures looks like this. And now look at the test statistics, negative 2.13. So negative is going to be goes like here. And where's your p-value? P-value is talking about the area of the left tail plus the area of the right tail. Okay, we only have the test statistic on the left hand side here. So let's try to find out the area from the left. Area to the left, normal CDF, lower value negative 1e99, upper value is going to be negative 2.13. This is only the area to the left. Use your calculator. You're going to see this guy. So now I find out the area to the left. How can I find my p-value? You're gonna multiply by 2, right? Multiply by 2. We assume the left tail, area of the left tail will be equal to the area of the right tail. So we just multiply by 2. Okay, now compare with your significance level. Should be less than or equal to or greater than. It will be less than or equal to, right? So if p-value less than or equal to the alpha, should be reject or fail to reject. Reject. Okay, one more time. This is how you guys perform the p-value method. Use the test statistic to find the p-value and compare with your significance level. Make sure you guys understand the concept of the p-value method. We'll be using the p-value method for the rest of the chapter 8, 9, 10, 11, and 12. Okay, second method, critical value method. The critical value method is based on the idea that we should reject the null hypothesis if the value of the test statistic is unusual. When we assume H0 to be true, in this method, we choose a critical value, which forms a boundary between the values that are considered unusual and the values that are not. The region that contains the unusual value is called the critical region. Okay, let me review a little bit from here. Okay, remember that we talk about it. If you look at the test statistic, it's located inside the alternate hypothesis. We know this is going to be reject. If your test statistic located in here, the null hypothesis, we know this is going to be fail to reject. This is the idea to draw the conclusion, right? And we say we can't compare with the z-score with the area of the alpha because this is a two different things. So the first p-value method, we try to use the test statistic to find the p-value, and p-value compare with your significance level to draw the conclusion. And this is the first method, p-value method. Second method, this is called the critical value method. It's exactly the same idea. Instead of use the test statistic to find the area, we could use the area of the alpha to find the critical value. Okay, one more time. Use the area to find the critical value. We could find out the critical value from here, another z-score. And we're gonna compare this critical value with the z-score from here. Okay, so this is exactly the same method, but we're just doing another way around. So this time we use the alpha to find the critical value and then compare with the test statistic. In here, we call this is gonna be the alpha, okay, the level of significance. And also, alpha will be equal to our critical region. Okay, this little tail, we call this is the critical region. If they given the area, can you guys find out the z-score from here? Yes, right? We learned it from the chapter 6. When they given the area, we want to find the z-score, we'll be using the inverse norm. And this z-score, we call this is a critical value. Okay, this point will be the critical value. And then now we're gonna look at the test statistic. If your test statistic located in here, we're gonna say if the test statistic is in the critical region. One more time. The tail here, we call this is the critical region. If the test statistic in the critical region, we're gonna reject. If your test statistic is going to be located here, if the test statistic is not in the critical region, okay, critical region is here. So if we located here, this is not in the critical region, will be fail to reject H naught. Again, p-value method and critical value method, they should get the same conclusion, same answer. They just work on a different direction. But you guys need to know both of the method, okay? P-value method and also the critical value method. Okay, now let me show you guys with the white tail and also the two tail. One more time, use the alpha to find the critical value z and compare with the test statistic z. So this is the conclusion. You guys need to highlight it and remember for it, okay? Remember, test statistic in the critical region, reject. Not in the critical region, fail to reject. So the left tail, I show you guys that this is gonna be your critical region. Use the critical region, the alpha, find the critical value of z. White tail, your critical region is gonna be on your white tail here. Use the alpha to find the critical value z in here. If you have a two tail, the alpha will be equal to the area to the left plus the area to the right. So that means if your alpha equal to 0.05. What is the area for each tail? One more time. If alpha equal to 0.05, what is the area of the each tail? You're going to divide it by 2, right? So that will be 0.025, 0.025 here. So keep in mind, highlight for it. If you have a two tail, make sure you're going to be divided by 2, find out the area of each tail. And also, If you're working on the left-tail test, your critical value should be negative. Okay, if you are working on the left-tail test, your critical value should be negative. If you're working on the right-tail test, your critical value should be positive number. Think about it. How about two tails? If you're working on the two-tail test, you should have a two critical values, one positive and one negative. Okay, keep in mind, if you're working on two-tail, you should have a two critical values, one positive and one negative. Okay, let's do another example. We do the example 4, but this time we're gonna use the critical value. So you could see we may have a more than one. It depends on your left tail, right tail, or two tail. And we have the original claim statement here. So write down the null and alternate hypothesis. We covered this part already, right? Okay, right tail test. So first, can you guys tell me what is the area of this right tail? It should be equal to your critical region, equal to the alpha, right? So that will be equal to 0.05. Okay, alpha is given. So the area of the white tail here, that will be 0.05. Now we want to find out the z-score. We want to find out what is the z-score in here. That will be called critical value. So first, figure out what is the area from the left. Total area under the curve is 1, right? So 1 minus 0.05, which is 0.95 here. And then, how can we find out the z-score if we know the area from the left is 0.95? We'll be using the inverse norm, right? Inverse norm. So use the calculator. You're gonna get 1.645. Okay, so I have my critical value equal to 1.645. Now we're gonna use the test statistic. The test statistic given is 1.45. Think about it. Where is your test statistic located? It's gonna be inside the critical region or it's not in the critical region. So remember the z-score in the middle here should be 0, right? 0, 1, 2, 3. So 1.45 somewhere like here. So my test statistic is not in the critical region. We're gonna fail to reject. Same example, we're gonna use the critical value method. So write down the null and alternate hypothesis. This is gonna be the two-tailed test, right? Okay, we have this picture. So first, figure out what is the area of each tail. We have a 0.05 here, right? The 0.05 talking about the area to the left plus the area to the right. Right now I have a two tail, so I'm gonna be divided by 2. So it's gonna be 0.025. Okay, I want to find out the z-score here. So we'll be using the inverse norm 0.025, which is gonna be negative 1.96. And remember, when we have a two tails, so we have a two critical values. So plus minus 1.96. okay, plus minus 1.96. We have two critical values. Okay, my test statistic is going to be negative 2.13. So think about it. Where is your test statistic located? Should be in the critical region or is not in the critical region. Negative 2.13, somewhere like here. So this is in the critical region. We're going to reject the null hypothesis. Okay, so we know how to use the p-value method or critical value method to draw the conclusion about the null hypothesis. Now, we need to know how to write the final conclusion, the final works in here. So you should have the chart in here. First, you're gonna look at the original claim. Is your original claim go to the null hypothesis or go to the alternate hypothesis? And then think about it, it's going to be reject or fail to reject. Reject or fail to reject. Okay, and from now on, we will be using this conclusion for chapter 8, 9, 10, 11, and 12. So I would call this is going to be my number one conclusion. There is sufficient evidence to warrant rejection of the claim. Number two conclusion, there's not sufficient evidence to warrant rejection of the claim. Number three conclusion, there is sufficient evidence to support the claim. And there's not sufficient evidence to support the claim. Okay, so this is called 1, 2, 3, 4 conclusion. Let's try an example. Assume a significance level alpha equal to 0.05. Original claim. The proportion of male golfer is more than 0.3. Hypothesis test result in a p-value of 0.035. So first, state the original claim, the null and alternate hypothesis. Find out the claim statement. Proportion of male golfer is more than 0.3. Remember, decide which population parameter you're working on. Proportion, mean, standard deviation, or variance. Obviously, they're saying proportion, right? Proportion. More than 0.3. So P strictly greater than 0.3. Figure out the null and alternate hypothesis. Okay, your null hypothesis should be less than or equal to. Alternate hypothesis should be strictly greater than. Okay, B. State the conclusion about the null hypothesis. This is talking about only reject and fail to reject. They given the p-value is going to be equal to 0.035. Okay, now we're going to compare with your p-value with your significance level. Should be less than or equal to or greater than. It should be less than or equal to, right? So if p-value less than or equal to the significance level, should be reject or fail to reject. Reject, right? Reject. Okay, state the final conclusion. Final work, so we're gonna use this chart here. Okay, look at the original claim. This is my original claim. It's gonna be go to the null hypothesis or go to the alternate hypothesis. It's gonna be the alternate hypothesis, right? They're exactly the same thing. So in here, original claim, go to the alternate hypothesis. So either number 3 or number 4 conclusion. Do you reject it? Yes, we reject it, right? Reject. So you're gonna use the number 3 conclusion. So you're gonna say there is sufficient evidence to support the claim that the proportion of male golfer is more than 0.3. When you guys write down the final conclusion, I need the complete sentence with the claim statement here. Okay, don't put dot 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 from here, don't put the original claim. I want you guys write it down with the complete sentence on the homework and the exam. And one more time, make sure you guys remember this chart. I'll be using this 4 conclusion, 1, 2, 3, 4 conclusion from chapter 8, 9, 10, 11, and 12. Okay, type 1 and type 2 error. Whenever a decision is made, there's a possibility that it is the wrong decision. And there are two ways to make a wrong decision with the hypothesis test. So look at the chart here. If the H0 is true, we may make a mistake to reject it. This is your decision. So we call this is going to be the type 1 error. Or if the null hypothesis is false, so we suppose to reject it, but then we fail to reject the null hypothesis false, we call this is going to be the type 2 error. Okay, or we may make the correct decision. If this is false, we reject it, so this is a correct decision. Or if this is true, we fail to reject, so this is also the correct decision. So try this example. The dean of a business school wants to determine whether the mean starting salary of graduates of her school is greater than 50,000. She will perform a hypothesis test with the following null and alternate hypothesis. Okay, so they given the null and alternate hypothesis. The null hypothesis is gonna be the mean starting salary of graduate of her school is less than or equal to 50,000. And alternate hypothesis is going to be greater than 50,000 here. So suppose that the true mean is 50,000 and the dean rejected. Is this a type 1 error, type 2 error, or a correct decision? So think about it. The true mean is equal 50,000. Which one has an equal sign? This one, right? So that means the true mean is 50,000. This guy is supposed to be true. The H0 is true. But then the dean rejected. Okay, so reject this one, should believe the alternate hypothesis true. Obviously, should make a mistake. Is this some type 1 error or type 2 error? That will be the type 1 error. Okay, try to do B and C. Suppose that the true mean is 55,000 and the dean reject the null hypothesis. Is a type 1 error, type 2 error, or correct decision? So think about it, 55,000. 55,000, this is a strictly less than, right? And this is greater than 50. So suppose alternate hypothesis is true. This guy is true. And then the dean reject this one. Okay, reject this one. So should believe this is true also. So this is going to be the correct decision. Okay, last one. The true mean is 55,000. So 55,000 so should be this guy. And then the dean does not reject it. She does not reject it means she believe this is true. So she make a mistake and we call this is going to be the type 2 error. Okay, so the session 8.1, this is the summary for your session 8.2, 8.3, and 8.4. And these sessions, we didn't really cover the specific population parameter. And instead, I just introduce how to write the original cam, the null alternate hypothesis, how to perform your p-value method or critical value method, and how to draw the conclusion. Session 8.2, 8.3, 8.4, we're going to combine everything together. So keep these notes and this is going to be your summary for your chapter 8. That's it for session 8.1.